Labguy here. This is PhiloCam Part 7 and Part 2 of the new video format and sync generator series. In trying to edit Part 2 yesterday, I discovered that with my new camera arrangement, this was a great idea, but unfortunately all we got was lots of pictures of the top of my head. You couldn't see anything. So in today's edit, two things. I'll show putting in the first wire, then we will jump to the final assembly, because I know for the second thing you guys don't want to sit through another 35-40 minutes of watching me wire the board, and that's if I'm lucky I can reduce the 4 hours of raw footage to 20 minutes or 30 minutes. So I hope you enjoy today's video, which will be extremely foreshortened. You're welcome. And we'll get right to the point, and we'll take it from there. The crystal oscillator's down here, he's U1. And then the LSB counter is U2, U3, and U4 to the MSB. And that would be U1, U2, U3, U4, U5, U6, U7, U8. Me Labguy. Alright, so U5 and U6, this one and this one, are the sync generator memory and sync generator latch. U7 and U8 are the video test pattern memory and video latch. So for now, we're going to wire all of this up, but at that point I will then begin the development of the sync generator PROM, the flash memory chip that goes in here. And that will be a software project based on Quick Basic 64. I'll give you guys time to stop laughing. I know, you're rolling on the floor, kicking your feet in the air, wiping tears from your eyes. Laugh all you want when you see how quick and easy it is going to be to generate the binary patterns for this without having to go through the nightmare of C programming. You'll see why I've chosen it. So we're to the point now where we need to go through, if you look at the counter chips, you'll see that for this first counter, pin 12 needs to be grounded to enable it. That is the counter enable pin. The next chip up takes the ripple carry out of the first chip, which is here, and comes around and is the second chip's enable. So every time the first chip carries, the second chip will count 1. When he carries, when the second chip carries, his ripple carry output will connect up to the enable input of the MSB chip up here, and he will count by 1. And this will continue until in the memory we reach the memory location that's the end of the count, which is 266,666. Then we will output on this bottom bit here, on D0, we'll output a low. It's high, and all other times it will output a low, which will loop back around to these 3 counters and reset them to 0. That's what closes the loop on the state machine. The states are actually burned into the memory, and being that these are flash memories, when, not if, when I program them incorrectly, I could go back and make the necessary changes and reprogram them without throwing away a pile of one-time programmable parts, which gets very expensive, as many of my former employers know. So onward and upward. So we're going to connect the first enable. So the pins that will, the chips that will have enables on them will be U2, which has pin 12 grounded. Oh, excuse me, pin 12 and pin 14. We have to enable the output. The outputs of these counters are tri-state. I'm going to be running them always on, so we need to ground pin 14, which is the output enable. So before I do any wiring, you notice I go through and wire the pull up and pull down. Those pins that are permanently pulled up and pulled down, I wire them first. But I'm actually ahead of myself, aren't I? I need to wire the red wire to all of the VCC pins, but that could come later, that could be done now. It doesn't matter, but I think I'll do it first. So we'll do that next. Here's another neat trick that I do. First we strip off about an inch, 2 inches on that end. Then I start, I'm probably going to get in your view. I can't help it. I have to be on high magnification. So take the wire and I lay it right by the capacitor, so the insulation is right there, the contact point, like that. And then I take my tweezers and I make a mark and I strip that. Alright, then I go from that second point around to the next point and mark it. And I go about 25 mils farther than I need, so I have a little bit of slack in the wire. And then from there to the next one, I do that all the way down so that I pre-strip all of those jump points. So let's see, that's alright. Now it's just a matter of soldering them to each point. We'll start at the beginning. And there he is. I use the tweezers to slide the insulation down. Hook the wire around like that. Of course it wants to fight. And just repeat this all the way down the line. And there we go. Now we do the enable pins. So on U2, which that's U1, U2, 3, 4, 5, 6, 7, 8. On U2, pins 14 and 12 go to ground. Cut them off, ready to move on to U3. U2 has 14 and 12 grounded. And there we go, the first 3 chips are enabled. Alright folks, you can't really see it, I've got my lab coat on, but it is getting to be summertime here. And it's actually getting hot in this room, so I'm going to take the lab coat off. There it is. That's the entire wiring of the state machine. We'll stuff the chips in there in a moment. This is right side up. For me. Alright, it's time to put in the chips. The first one is the oscillator. And I've cut the pins kind of short, and as a result it will fall out of the socket pretty easily. And it's just good practice if you put one of these in a socket to put a bail wire over the top of it to hold it in. I've already cut this one. I'm going to put that in. Press everything down tight. Just grab it with the pliers. And bend it over. When I'm certain it's working, I'll solder those so that the chip doesn't fall out. But there you go. The oscillator is now held in with the bail wire. I can't see my viewfinder. Of course, now it turned upside down. There we go. Okay. Next is the counter chips. You have to bend the pins. Brand new chips have the pins flared a little bit. Make sure we get the right part, put it in the right way. That's one. And then when it comes to these memories, this one's still. This is what they look like. And they go in easily enough once you line them up. Press till they click. And of course, these are just for show. Because they're not programmed yet. But the entire state machine is complete. This is how I look at it. Right side up, that is. But Labguy, how the hell do I get these memory chips out of these sockets? Well, I'm glad you asked me. You need this tool. Besides being very useful in getting people to tell you the truth, we have ways of making you talk. It's also good for pulling these chips out of these sockets. Little hooks go in the sides, and you squeeze it and just pull the chip out. And I'm going to leave them in for now since I'm not ready to program them. And for some reason my programmer either doesn't like these two chips, the four, I bought 4 of them, or the adapter that they go into for the programmer is defective. I did verify that the programmer works. There you go. That will produce all of the sync pulses and up to 4 test pictures when it's done. This PROM will contain the sync pulses, and this one will contain the image data. So that summarizes the assembly of the board. If you like this video, click that thumbs up button. I really appreciate it. And tell your friends. I think this is going to be a very exciting project. And until next time, Labguy out.